So example number 4 says to make a force diagram of a student pushing a cup across the table. So using our SID method, the first thing I need to do is sketch the object. Again, does not need to be a masterpiece. Let's do a little cup. And someone pushing the cup. Alright. So the way I have drawn my picture, the cup is going to ultimately go to the right. Depending on which side you put your person on, your force diagram may look a little different as long as you have all the same stuff that I do. Just apply it to the way that you drew your cup. Anyway, so we've sketched the object and crossed that off. The next thing we need to do is identify the forces. We are on Earth, so of course we have gravity. There's a person in it touching the cup, so that tells us that there is human force. This cup is not falling because the table is holding it up. Therefore, we know it is being supported. And as the person slides the cup across the table, it is rubbing on the table. So therefore, we also have friction. This is very similar to when you slid the box across the table in the demonstration lab. So the first thing the next thing we need to do is identify the forces. Again, we need to make sure that they're identified on our picture, otherwise it does not count. So we're going to say gravity, support, human, and friction. Now I can say I have identified the forces. The last thing we need to do is draw the arrows. We know that gravity is going down. We know that support usually goes up. That is also the case for ours here. Don't worry about if your forces are in a different order than mine. That's fine as long as you have all the same information. According to my picture, again, the human is pushing the cup to the right, so I am going to label my human as going to the right. Again, if yours is opposite, then go opposite. Friction. Friction is a counterforce. Friction always goes against the motion of the object. Kind of like air resistance, how you put your hand out the car window. Friction is going against the object when you push it or pull it. As if you were sliding something across a carpet, it would be a lot harder because the friction is pushing against you. Therefore, there's going to be lots of friction in the front of our cup pushing against us. That means that since our cup is going to the right, friction is going to go to the left. Now, the last thing we need to think about is the size of these arrows. And we actually have a unique situation here where we have both balanced and unbalanced forces. We need to think about both vertical and horizontal. In this case, vertically, the cup is not going anywhere. Vertically, it's not floating up in outer space. It's also not falling to the floor. So on a vertical axis, it is actually balanced. It's not moving up or down. So gravity needs to be the same size as support force. Horizontally is a different story because I am pushing the cup to the right, so therefore horizontally we are going to be unbalanced and we're going to have a force that is bigger than another force. So we are going to have human is pushing the cup, so it's going to be bigger than friction. And it's unbalanced. So when it comes to drawing our arrows with the correct size and direction, we're going to have gravity going down, support going up. However, they're going to be the same size, and we want to make that as clear as possible, as close as possible. Okay. Alright, now when it comes to human and friction, we need to make sure that human is bigger than friction. We know that human force is going to the right, friction is going to the left. Human is going to be the biggest force out of all of them, and friction is going to be a lot smaller. And that's what I'm talking about when I say exaggerate it. Make it obvious. This is obviously a lot bigger than this. Therefore, when I look at these two, even if they're not, if I were to get a ruler, they weren't and are a millimeter off, that's okay because I can see when I look at this whole picture that these are pretty much the same size. These two are obviously unbalanced and that this is so much larger, so obviously the cup is going to the right. So we have now just drawn the arrows to the correct size and direction. Keep in mind that this is my force diagram, and I have all the pieces on it, so therefore I have drawn it successfully. Everything else to the side was all just brainstorming. If you feel at this point you don't need it anymore, that's okay. You will not have all of this on the test, but you will need to be able to draw what's in the box.